Okay, Algebra 2 is moving on to absolute value equations and inequalities. So remember absolute value, distance from zero, so when you have a negative number, absolute value comes out positive. Same thing when you have a positive number, and that's summarized right over here. So remember that that definition of absolute value is a distance, and a distance can't be negative. You can't say you live negative 2 miles from Spratley. Which direction would you go exactly if you wanted to go negative 2 miles away from Spratley? It just doesn't work. It just doesn't make sense. So absolute value has a lot of really convenient real-world applications when we think about, for example, a factory that is manufacturing bolts. Okay, so what I mean by bolts, I mean like a screw that would be something that would go into just bear with me, you know, I'm not much of an artist. That would go into the pieces of a car that are held together. Well, it's got to be a particular size. It's got to be very specific, but it's not going to be exact because machinery is not exact. There's a wiggle room that's actually called tolerance, and it's something you'll see in a word problem later on, whether it's in this video or in class, I'm not sure, I can't remember. But the tolerance of an object is the distance on either side of the acceptable size that you can go and still be acceptable. So say, for example, that the diameter of this bolt had to be 2 millimeters. Well, the tolerance might be within 0.002 millimeters. So what that would mean would be that you could have one that's 1.998 millimeters, but you could go up to one that's 2.002 millimeters. So that's tolerance. And a lot of times to solve those equations, you actually use absolute value, whether it's an equation or an inequality, depends on the circumstance. So let's jump in and take a look at how you solve absolute value equations. Solving absolute value equations. Okay, so absolute value equation would be one in this format where you have an expression involving x that's equal to 0. C has to be greater than 0, because if C is less than 0, you automatically have an equation that is patently false. You can't have the result of an absolute value be less than 0. So what you're going to do to solve these is you're going to write two equations. In the first one, you just drop your absolute value bars. In the second one, you drop your absolute value bars, and you make that constant that's on the other side, you reverse the sign of it. So if it was a positive, you make it negative. This is because the inside part of an absolute value could be a positive or a negative, but after you take that absolute value, that's when it becomes positive. Now that you have two equations, you're going to solve both of them. Then you check your solution by plugging it into the original equation. Let's give it a shot. Okay, example 1, we have a simple absolute value equation. We have x minus 5 is equal to 7. Excuse me, the absolute value of x minus 5 is equal to 7. And they want us to graph the solution, and that's just on a number line. So we're going to solve two different equations. Let's switch to a pen here. Two different equations. We're going to solve x minus 5 is equal to 7, and we're going to solve x minus 5 is equal to negative 7. All right, so in both cases we're going to add 5. That's going to result in x equals 12 here on the left. Same thing, x equals negative 2. So we've solved both equations. Now we're going to check both solutions that we got. So the absolute value of 12 minus 5 is indeed equal to 7. And the absolute value of negative 2 minus 5 is also equal to 7. The insides there would be negative 7. Take the absolute value, positive 7. To graph that solution on a number line, it's very simple. We would go ahead and draw our number line. So I'm going to put 0 here. I'm going to put in negative 2, and then I'm going to put in 12. So I'm not going to put all the detail in between. I don't really need it. But I'm going to take on that graph there, and I'm going to put a nice dot at negative 2, and I'm going to put a nice dot at 12. And that would be the graph of that solution. Not something that seems really all that necessary, but I think it's just a precursor for us graphing the inequality ones. Okay, moving on. Example 2. Solve a more complicated absolute value equation. Okay, so again, you're going to solve two equations. So here's what I want you to do. I want you to pause the video. I want you to try it out, get your two solutions, and check them. Notice it doesn't say anything about graphing the solution this time, thankfully, because that seemed utterly pointless. So go ahead and do that, and then press play, and you'll see the result. Okay, so here's your result. Did you get 11 and negative 7? Or really negative 7 and 11? I hope you did. Let's double check our answers. Yes, indeed, both of those solutions do work. So when we write our final answer, We usually write a set of curly braces. Be careful not to make it a set of parentheses. Make it a set of parentheses that looks like an ordered pair. And this equation only has an x in it. So you can't have a solution to this that would be an ordered pair. That would have to have an x and a y. All right, let's trudge onward. Okay, this one is a little bit different because you have the absolute value expression here on the left, and you have an expression that doesn't have an absolute value, but it does have an x in it on the right. But we do the same thing that we were doing before, so you're going to solve two equations. Let me pause it for a moment and write them. And here they are. So now we're solving these. It's going to be a little bit different. So instead of dealing with a constant, we're going to be dealing with our x values, our linear term here. So we're going to take 2x off of each side. 12 is equal to 2x, which means x is equal to 6. Okay. Over here, we're going to take 2x off of each side as well. While I'd love to add 4x to each side, that will give me 0 on the right, and that's not very convenient. So 12 equals negative 6x, and x equals negative 2. So let's now go back to the original equation and check those answers. So when you check those answers, you're going to plug them into the original equation, putting the absolute value bars back where they belong. Oops, didn't mean to do that there. Let's fix that. So we're going to plug in a 6. And we're looking to see if the two sides are equal. So that's 12 plus 12 inside, so that is 24. And the absolute value of 24 is indeed equal to 24. So that one works fine, and 6 is a solution. Over here with a negative 2, we're going to plug in our negative 2. 4 times negative 2. And I'm already seeing an issue here, but let's keep going. All right, so we have negative 2. 2 times negative 2 is negative 4. Negative 4 plus 12 is 8. So we have the absolute value of 8 there. And we have negative 8 on the other side. Now that's not going to work. Those are not equal. So that means that the number 2 cannot be a solution here. And the only correct solution in this circumstance is x equals 6. So the only solution for this problem is the 6. And the other one is what we call an extraneous solution. Extraneous. Okay, oh, it says it right up here. Look at that, extraneous. So negative 2 doesn't work, 6 does. All right, so that's not too difficult. Let's move forward. Okay, absolute value inequalities. Absolute value inequalities have two types, okay? And I believe we talked about from the previous class, we talked about our compound inequalities. Compound inequalities, those ands and those ors. So take a second, peek at your notes or your work from last class, and I want you to look at your and and your or inequalities. Well, right up here you have your and inequalities, because you can have a number that is both less than c and greater than negative c. Down here you have your or inequalities. It's impossible for a number to fit both sides of this at the same time. So the absolute value inequalities and the compound inequalities have a very close similarity. So notice that when you have the absolute value of the expression is less than c, that means that insides of that absolute value are less than c and at the same time greater than negative c. Same thing if it's an or equal to. If, on the other hand, your absolute value is greater than c, you have an or situation, since you obviously cannot have both a value that is bigger than c and less than negative c, or the opposite of c. That just doesn't work. So let's actually put this into practice by solving a couple. Here's our first one. So when we write our two separate inequalities, similar to writing our two separate equations, for the first one you are simply going to drop the absolute value bars and keep everything else. So that's one of them. In the other one, you're going to drop your absolute value bars. You're going to flip your inequality symbol, and you're going to reverse the sign of that constant on the other side. Because if the absolute value of this is bigger than 13, that the insides of it are either bigger than 13 or they're less than negative 13. In which case, then you'd take the absolute value of that and you'd still get that bigger than 13. Okay, now that sounds a little complicated. Rewind it and listen to it a couple times, and if it's not working out for you, jot it down as a question to ask when you come to class. Now solving these, same as solving equations, so I'm going to subtract 5 from each side. I'm going to get 4x is greater than 8, and then we'll end up with x is greater than 2. Subtract 5 from each side of this one. End up with 4x is less than negative 18. And that one's not going to go evenly, so x is less than negative 9 halves. And this is an or situation. You either have some number that is greater than 2, or you have a number that is less than negative 9 halves. And you can graph this. So you're going to draw your little number line. You're going to go ahead and mark off negative 9 halves, and negative 9 halves would be negative 4.5 or negative 4.5. I'll put in a 0 here, and then I'll put in a 2. Okay, now we know that x is greater than 2, so that means x cannot equal 2. So we put an open circle around the 2, and greater than means we're shading and coloring in our arrow going upward to the right. Then also, x is less than negative 9 halves or negative 4.5. So again, an open circle, and this time shading down, filling in the arrow. So there you have the solution to this absolute value inequality. Let's try another one. Well, this time we're going to talk about that tolerance problem. A professional baseball should weigh 5 125 thousandths ounces with a tolerance of 125 thousandths of an ounce. Write and solve an absolute value inequality that describes the acceptable weights for a baseball. So, what we have here is we have a situation where you have a variable, so x represents the weight of a baseball. And in order to write a tolerance inequality like this, an inequality for this tolerance problem, what we're going to say is we're going to say that x, the weight of the baseball, minus the official weight, what it's supposed to be. Okay, so if we were to take whatever the actual weight of the baseball is and subtract the weight of what it's supposed to be, that the difference between those two is supposed to be within 0.125 ounces, but it could be on either direction. So the way this works is you put that inside the absolute value bars, and you say that that difference has to be less than or equal to the tolerance. That means that when you solve the inequality and you write the two separate inequalities, you have the difference between the baseball and the expected weight is less than or equal to 0.125. And at the same time, you have that difference must be greater than or equal to negative 0.125. So in other words, it has to be between negative 0.125 and positive 0.125. And when you solve that, you end up with x is less than or equal to 5.25 when you add those together, because you're adding the 5.125 to both sides, adding 5.125 to both sides, and you get 5.25. And over here, you're doing the same thing. You're adding 5.125 to both sides. You end up with x is greater than or equal to 5. So, if x has to be greater than or equal to 5, but at this, like 5.0, if we want to be scientific about it, because that actually matters. That actually does matter there, 5.0. And at the same time, less than or equal to 5.25, that shows that you have a tolerance of that 0.125. So these are the acceptable weights for the baseball. It could be between these two weights, and that's what is acceptable. So, I like to try to finish your video out or start it out with something funny, and this one started with a picture of absolute value. So I'll finish with a picture that I found very amusing. So remember, when you're driving along a cliff, always watch out for falling cattle. Okay, kids, I'll see you in class.